VGW, for those who haven't heard, we're a gaming company. We have a bunch of different products like poker and casino and whatnot. We have a product called Chumba that Matt is the dev lead of. We have, our main office is here in Perth. We are a fast growing company. We're hopefully going to be listing on the ASX pretty soon. We've got data scientists, we've got DevOps, we've got all these wonderful things. But we're also tackling a lot of the problems that a lot of you guys will be probably tackling as well, coming from enterprises and startups.
I'm Matt James. As Rhys mentioned, I'm the dev lead for Chumba Casino. So we're a social casino, operates on the web and in the US. And we have a tech stack which was really suitable at the time when we were developing games really fast. And we now have over 30 games in our casino. We're now looking to be more flexible and nimble and develop even more features as we scale. So that's where we're at.
So my name is Rhys, and we have a Monolith.
Yeah.
So we have a really good product. It's in production. It keeps our shareholders happy. It keeps our users happy. Is that feedback coming from one of these? Right, cool. Yeah, so we've got what we think is a really good product. We've got what our shareholders and customers think is a really good product. Devs, not so much. The guys don't love working on it. They know it makes people happy, but their day-to-day lives, it's a little bit hard because it's such a big product. Historically, it's been slow to deploy. We've brought on people like Jeff Stewart to help us with that, improving our DevOps processes, but it's still a very highly coupled system, and so we've had issues with that.
I just want to add to that as well, like it's also becoming a problem a little bit for the business as well now, because they're wanting new features quite fast, and they don't want to compromise on anything like performance and other things like that. So we are starting to face problems both on the dev side and in the business side with the current architecture that we have.
Should probably add that from our business point of view, they're pretty aggressive on how many customers they want, and we've got to be wary that even though we're doing really well at the moment, the orders of magnitude they want to grow at is pretty terrifying. So we need to be wary that we have to be able to cater for that long term.
That's it.
Yeah.
So we decided to take a service approach to some of our newer features, particularly microservices, but I feel like that's quite a loaded term. Rhys has helped introduce a lot of new ideas and new architectures into our stack, and we've slowly been like sort of thoroughly testing these and figuring out which one is the most appropriate. We wanted to take a service or a microservice approach because it eliminates regressions to our existing features, of which we have many. So that's a big win in itself. If we can build something separately, then there's no chance that we're going to introduce a bug in an existing game that we have. We can rapidly prototype services, so because we're not constrained by our current architecture and a new service, we can just like bust out a new feature and have our game designers or our product managers take a look at it straight away. It also means, same as the regressions and bugs, there won't be any performance impact on our core features. It separates responsibilities, which we all know is a good thing, and it also feels like a fresh start because we can start fixing the things that we've been sort of looking at for months and even years now, and thinking, oh, we really need to fix that, but it's so hard in our current architecture. So I feel like the service approach is the right one. But that is such a broad term that we need to now start refining it. And one of the things we looked at but didn't get to was serverless.
So I think a few of you here may know that Matt and I are pretty big fans of serverless as a concept and serverless the product. So it's probably a little bit odd for people to realize that we actually have not gone with serverless for these new services we're approaching. One of our jobs is obviously not to just build software, but to meet the expectations of various stakeholders. So we've got people that need to be kept happy, like our security, governance, auditors, and we've also got to keep our devs happy. Serverless ticked a lot of boxes, but it also didn't tick a bunch of boxes. We have a very nice deployment stack that helps us deploy our current monolith, and we really didn't want to throw that away just because new shiny. So we've looked at basically building microservices, not using serverless, but using better known stacks, and leveraging that existing those DevOps models that we've got. Serverless is also still a V1. There's a couple of security issues that, albeit light, just make it a little bit grey for us. So we decided to kind of stick with what we know. One of the other big things when we kind of started looking at pricing, the model we've picked really is it's pretty comparable or lower total cost of ownership when compared to, say, Lambdas. So we're pretty happy with that decision. Yeah.
Yeah, so just want to add to that a little bit. So although we didn't choose serverless, we still wanted to get a lot of the benefits that serverless offers, and we thought hard about how to achieve that in our some of our existing infrastructure and some of our existing stacks. And we didn't want to compromise on things like fast deployments and just simple and ease of integration with our existing infrastructure. And Jeff, our DevOps lead, was a great help in doing that, and wrote a lot of the infrastructure which allows us to do something like this. So this is a thin layer over the top of our enormous infrastructure code base, which simplifies things for developers. So this is how we create and deploy a new service. And I'm going to demo this in just a second, but I'm going to run you through sort of the high level aspects of it. So it looks similar to a lot of your CLIs that you will see in serverless or in things like Heroku or anything else. We have the option of Java or Node as our language of choice, our platform of choice. So it's a good abstraction for our services. It's simple and version controlled config, which I'm going to explain a little bit more detailed. And it's not coupled to the deploy code. So for example, if we wanted to use serverless and we wanted to basically replace our existing deployment with serverless, we could do that under the hood. And the developer doesn't need to know about that. They just need to know that these are the commands and they will be the same even if we move infrastructure or platform. Basically, we have this CLI interface, and as you saw, it was a VGW service and then a command. So some command here. What I've got is VS, which just maps is an alias to VGW service. So I'm just going to use VS because it's a lot shorter, a lot more sort of, we can just concentrate on the important parts. So let's just create an app. So I'm just going to call it my app. The language is going to be Node. So we go VS create. We've got a template repository, so which contains just the raw stuff that we need for a basic service. So you can see that it's just a plain old Node app. All it's got is an index file, a package file, and it's got this VGW YAML as well. And this just defines how we're actually going to start this service. And of course, if by just changing the stuff in this YAML file, we could deploy any language and any type of service with any particular runtime arguments or anything like that. So we have control over that just with this config file. But let's ignore that for now. So what we're going to do is I'm just going to run you through, let's say we need another config item. So we need an environment variable, as all our config is environment variables. So we're going to go VS config set. So the key is my new value. I'll just escape the bang because that won't work otherwise. And we're also going to encrypt it.
So that encryption is using AWS's KMS. So Matt's got his role set up locally to be able to encrypt, and then the service will be able to obviously decrypt using that same service once it gets deployed.
Yep. So this just actually injects a config file just here. So we can commit this, and we can version control all our config, which is great. This pattern is seen a lot in a lot of other deployment tools, like Travis CI actually uses this pattern as well, so it's pretty well known. So I'm just going to change this here. Okay, cool. And so then I'm going to build the app. I'm going to upload the artifact that is generated. And I'm going to update an existing environment with this new change of mine. The environment's called ChewDev, but don't worry about that too much. And I'm just going to redirect the output so that sensitive stuff isn't printed on the screen.
Security is always watching.
Yeah. So basically, guys, yeah, so VS Build will just like build a basic node app. VS Upload just uploads to our Nexus repository. So we just have all our artifacts loaded there, and this will just do the dev one. And then VS Update will just load that artifact into our environment, and hopefully we can see the change in our browser as soon as this is finished deploying. So won't take a second, and we'll come back to that in just a minute.
Probably one thing I just wanted to say, I don't know if we've made it clear before, our code, the code underlying that is doing this deployment leverages heavily the code we use to deploy the monoliths.
Yep.
So one of the massive benefits of that is we've had audits on our VPC architecture, so our AWS audits, our VPC architecture, subnet security groups, all of those kind of things have all been signed off by our friends at AWS and by our auditors. So by leveraging that with our microservice approach, we get all of that for free. We don't have to reinvent the whole entire wheel, which when we were starting to move down the serverless stack, we actually were looking at having to change quite a lot of our VPC architecture. So we don't kind of throw the baby out with the bathwater in this approach, meaning yep. For us to get up and running and be compliant was really, really, really quick.
Yeah, so, and as I said before, okay, that's just finished now. But as I said before, we're sort of standing on the shoulders of giants here, mainly Jeff's shoulders. But there's a lot of stuff going on in the background there, such as VPC peering, routing tables, like locking down security groups, all that stuff, but we don't need to worry about that. So, so this is the service that was running before, and hopefully, if I refresh this, we get latency woo, which is our config file, config variable. Yay!
Thank you, demo gods.
Thank you. Okay, sweet. Let's get back to the preso now. All right.
Cool. So we said we're not using serverless. As I said, we're big fans of it, but for this, we didn't feel it was the right choice. The framework was largely a dev's choice. So we've got superstar devs. So why not get them picking the tools they want to use? So TC here at the front, he's like, yeah, I'm happy with Java and Spark. So yeah, run with it. So Java and Spark and Postgres on AWS is what we went with. It's fast. It does everything we need. We can still build really tight, clean microservices in that. We are not deploying to Docker. We've kept it super simple. It's just chucked on EC2 instances using the VGW service CLI. And as you see, the deployment time was pretty quick. To me, that's comparable to something like an Elastic Beanstalk or a Heroku or deploying to Azure. We kind of got all of that stuff that we wanted. Java and Spark for us was a pretty good choice. The other option we've got is that we've kind of exposed is Node with Express. They're really good for fast prototyping. They kind of encourage you to keep your scope pretty tight. They're good for small, medium-sized services. So if you're going to build a monolith, maybe you don't want to use those, but then why are you listening to this talk? There's no container. The faster, we use kind of the fat jar model. It's explicit and declarative. It just makes everyone's kind of lives easier. So we're pretty happy with that choice that TC made. Moving forward, if we've got devs that want to do their stuff in Express, doesn't really matter. The contract set from Matt and my point of view is the HTTP level contract and the database, and as long as I've met all the security concerns within the VPC, if they want to use Express, go for it. That's cool by us. The only things we're tied in there is we're very AWS specific. We're all in on AWS, so if someone in the team's like, hey man, can I go to Azure? We're like, no, you can't. Sorry, like it's just, that's what we've invested in. And yeah, we've basically, our governance and security rules are all kind of kept in line there.
Awesome. One thing we did manage to avoid in this solution, so there's a particular service we're writing at the moment, and we've managed to avoid message queuing. So that's been a good thing for us because we know that adding technology to a stack is not additive, it is exponential. So for example, what happens if you need to handle retries, more than once delivery, out of order messages? Should it be polling or reactive? How does the message get consumed? Do our staff know how to use this, and can we hire people that actually do this? We need to operate and monitor things like message queuing technologies like ActiveMQ, RabbitMQ, or even the AWS equivalents. All these things, and we're also coupling ourselves to the structure and the contracts of that message queue itself on both sides of our services. So we wanted to avoid this if we could, and if we wanted to use it, we would need really good justification for all that work that would go into it. There are plenty of options that avoid message queuing between microservices, and one of them is just use your event store as your queue. So your event store in your database, if it's immutable, which all good event stores should be, then you can use that as a queue and keep an index into it and keep reading as you need to. And there's so many benefits to that as you invert the dependencies, actually. So instead of your primary service being dependent on sending a message to your other service, you've inverted the dependencies, so that service actually reads off your event store. It's fine. I'm not going to go into too much detail on that. Obviously, we've got synchronous messaging, so RPC and just REST is also a good sync messaging tool. We also wanted to avoid that a little bit because then there is more coupling involved. So what we actually managed to do, or what TC implemented and was able to work out, was this.
So we basically are kind of leveraging the browser. Our apps are pretty client-side heavy. There's quite a lot of logic going on in there, and we've decided we're going to actually use the browser as a broker. So we're effectively using a secure claim via JWT, so it's a JavaScript web token. So we're putting claims in those that one service can provide to the browser, and the browser can then use that claim to talk to another service and say, I've been authorized to do X. This was really clean for the use case that we're looking at. This was super clean for us. We didn't have to have some sort of MQ in the middle, which means, as Matt said, there's no kind of static thing which kind of helps us with our deployments. We don't have this equivalent of a database in the middle. We don't have to have a middleware team managing stuff. It's keeping it all just HTTP. We can test locally. We've got all of these things. The only things we're really coupled to now is a JWT spec, which is a very well-known and well-defined spec, and the claim structure itself. So we obviously need to know between services that this is what the claims are going to look like, and I need to know how to validate those claims as well. So we may have shared secrets between, or a public and private key setup.
I'm just going to check, because we do have time. Does anyone want to, hands up if you know how a JWT token works? Okay. About half, yeah.
Okay. So a JWT token is basically a way of me giving something a claim. So a claim is just something that could be like, this is this person's name, and I can sign this, and then that can be passed over to Matt, and Matt can say, how do I know that you're Rhys? I can validate that claim. So we can use basically encryption on that. There's a bunch of ways we can do that. Thank you. And it's a way of validating without me having to directly talk to Matt to say, oh, by the way, that third party has this. We can pass messages around to securely to validate what I'm saying is true for this third party. Does that make sense?
Yep. So without the two services talking to each other, they could have a message and we can verify it's from the other service, basically. Yep.
Yeah, cool. So here's a very simple kind of abstracted example. So Alice, let's pretend we've built Spotify, because we don't really want to go into the details of what we're building. So Alice is be like, oh man, Bob would love Spotify. I'm going to click on this button in Spotify to say I'd like Bob to be able to use Spotify. Click on the button and maybe it sends him an email. That invite service can create a claim, sign it, and send in that email that claim to Bob, where Bob's like clicks on the link, yeah man, that's wicked. That claim can now go to the account service with the claim intact. The account service can pick it up, validate it, look at the claims and say, oh yeah, this claim says Alice has given Bob 1 free month of Spotify. Yep, good to go. Replies back to Bob to say, yeah man, here's your 1 month free Spotify. What we can see here is that invite service, account service do not talk to each other. We don't have that coupling, and we don't therefore have that dependency graph that was talked about in the, sorry, it was Ryan's talk somewhere. We don't now have dependency chains going around in terms of temporal coupling, which makes life much easier. This is obviously not suitable for every use case, but for our use case, this is completely fine.
Yeah, and one of the main points here is that even if we did have the two services talking to each other, if we split the responsibilities right, they probably wouldn't be very chatty anyway. So we're not really sending a lot of these claims around because we have loose coupling between those services, so there's not a lot of these messages flying around. And for our use case, we actually did want the user to get a pop-up or window or an email and actually click like a button that says use my claim. So this worked really well with our whole user experience flow as well. It just fit in really nice. And it's not always going to for all your use cases, but for ours it did, and that was awesome. Yeah.
Yeah. You got that one?
What's that?
That's you? Conclusion?
Yeah. So I guess a couple of takeaway points from us is first is just don't overcomplicate things, and in fact fight to not complicate your life anymore. And we did that, especially like, and TC helped a lot with that, with fighting against sort of message queuing and all that coupling and things like that. Actively fight against that stuff. But we can't compromise on the must-haves, things like security, flexible choice of tech for anyone writing the service, and speed of tests and deployment are just like really key to rapid prototyping. So our architecture was minimal, but we thoroughly thought it through. And even though it came out simple, we did try a lot of different options, including serverless. But for this particular service, and probably for a lot of others, we'll probably use the same architecture as well. So anything you want to add, Rhys?
No, I guess that last point was pretty key. We actually thought about this. We didn't just rush into it. We slept on a few things. Our first cut didn't look anything like our final cut. We put things in, we pulled things out, and it distilled down, I guess. We had a bunch of crazy stuff in there on the first cut, and it came all the way back down to basically HTTP and JWT tokens. So I'm really glad we spent the time to do that, and hopefully it's made TC's life a lot easier. Yep, cool, good.
Yeah, awesome.
Yeah, that's us.
Thanks, guys. Thanks, guys.